Chapter 8, Terrestrial Planets. All right, so the terrestrial planets, of course, are the four inner planets. Terrestrial just means that they're Earth-like. They have surfaces. I mean, there's certain things that make them in common, um, and very different from the gas giants, as we're going to see later on. All right. Whoops. So this is actually a picture of Mars. We think that in the early stages of Mars there was actually liquid water on the surface. There's no longer liquid water on the surface. Of course, it's a very dry planet. There's frozen water that is locked up in the polar ice caps. It's frozen water and frozen carbon dioxide. But all right. So anyhow, we'll get to Mars shortly. This first thing is this first few slides are going to be an introduction to just the terrestrial planets. All right. So these are the four planets. Of course, Mercury. We're going to spend some time talking about each of these, right? Venus, our planet, of course, and then Mars. All right. So. They all have roughly the same size. In fact, Earth and Venus are basically the same size. Venus is just slightly smaller. Um, anyhow, Mercury is much smaller than all the rest of them. It's the smallest planet. Anyhow, similar size. Some are covered in craters. That would be Mercury, of course. Others have volcanoes and mountain chains, or not volcanoes that are actively going off, but they do have volcanoes and mountain chains. That would be, of course, Venus, Earth, and Mars. Now, Venus has a very thick atmosphere. Let's see. So I guess that's the next thing we talk about. Is some have atmosphere, some don't. Venus much thicker atmosphere than the Earth. It's made of mostly carbon dioxide. Mercury has no atmosphere, and of course, Mars has a very weak atmosphere, but it's also made of carbon dioxide. And this does have to do with the distances that they formed from the sun. All right. So anyhow, let's the gas giants are made of more icy material. We'll get to those in another chapter, which I think is actually chapter 9. All right. So anyhow, all right. So now we're going to concentrate on Mercury. They're still comparing. I noticed the other day when I was teaching this, and this slide actually should say Mercury and Venus, because the picture over here on the left hand side is Mercury. The picture on the right hand side is Venus. All right. So anyhow, Mercury is by far the smallest. It looks just physically a lot like the moon, right? It's covered with craters. It's not quite as gray as the moon, it turns out, but it is, it does look a lot very similar to the moon. Thus far, there's only been 2 missions that have gone to Mercury. The Mariner 10 in 1974, and it was in 2011. It was actually several years. 2011 through, I think, a good 5 years. There was another mission called Messenger, and Messenger is the one that gave us the most information. The mission in 1974 was literally a flyby. They did take some close-up pictures. The Mariner 10. I might have said Mariner 4 earlier. It was Mariner 10. It did take some close-up pictures of Mercury, but for a long time, that's all we had. That's the best information that we had about Mercury. and Venus is covered with clouds. It's in fact Venus is one of the brightest objects in the night sky because of those very thick clouds. So its atmosphere is about 90 times the atmospheric pressure on the Earth. And just to let you know, I was sitting in my office, um, trying to give a comparison, between what 90 atmospheres feels like. And so if you were on the Earth and right at the surface, right at where the ocean is, right? Of course, that's considered one atmosphere of pressure, and 90 atmospheres. Basically the ocean water, the salt water, increases in pressure about 1 atmosphere for every 10 meters. So once you get to around 90 meters or so, or a little bit less than that actually, but right around 90 meters down, you would be, it would feel like it feels at the surface of Venus. Just to let you know. I mean, that's there are humans that can actually dive down. Not everybody could do this, but there are people who could dive down into the ocean, with just like some snorkel, um, nothing, that special, like not special equipment, for example, and they can dive down to 100 meters and then come back up. So it is very intense pressure, but all right. Anyhow, that's just a good little comparison. It is the hottest planet in the solar system, even hotter than Mercury. And the reason that it's so hot, as a matter of fact, is because of its incredible atmosphere. Right? It's very thick atmosphere. It acts like a blanket. Basically, all the heat that comes in just stays. And in fact, we're going to call that the runaway greenhouse effect. There are huge volcanic peaks, and then there's plains. This is a picture of. One of the things is you might wonder is how is it that we can even take pictures, because you can't see the surface of Venus at all. You cannot see the surface of Venus. Um, there have been just a couple of spacecraft that have landed on Venus and took a few pictures, but because of the sulfuric acid in the atmosphere, as well as the crushing um, atmospheric pressure, those spacecrafts did not last for very long. They were called the Venera. That was the former Soviet Union, sent multiple spacecraft, even starting back in the 1960s. Back in the 60s, they didn't even get close to Venus. But eventually, I think it was in the late 70s, they actually landed a spacecraft on Venus, and one of the Venera, I forget what number it was, but they landed and took pictures. And again, the spacecraft only lasted a little over maybe an hour, 2 hours, something like that, before the electronics completely failed because of this. It's not a hospitable place for electronics. Sulfuric acid and really intense atmospheric pressure. Anyhow, how is it that we don't see these with visible light? The Messenger spacecraft orbited Venus for many years and took radar pictures of and mapped completely the surface of Venus. One more thing about the surface. So when the Messenger spacecraft went around Venus, one of the things, you might have heard this before. It's a common phrase. And there was even a book that was published with the title, "Men are from Mars, women are from Venus, and because Venus was the goddess of love, and Mars is the god of war, and so forth. And so that that's getting into a little of the mythology of these worlds. But anyhow, one of the things that NASA did with using the images that they got back, the radar images, is some of these features on Venus they named after female, but both mythical female characters, and even real people. Like, for example, there's a place on Venus called um, Cleopatra, and there's another place called Margaret Mead, for example. Anyhow, that's just a little point of interest. All right, so Mars, of course, is been studied multiple times. Of course, we live on the Earth, and we just had a chapter on the Earth. But Mars has been studied, and because it's most, even though it's smaller than the Earth, it's the planet that is most similar to the Earth in that it's tilted by about 24 degrees. It has polar ice caps. It's both frozen water ice and frozen carbon dioxide. The polar caps, by the way, grow and shrink with the seasons. There are craters and dunes. We think that there was water that covered the surface, parts of the surface of Mars, maybe even an ancient ocean. All right, so and there's places that look like dried up riverbeds. There's volcanic evidence, not recent evidence, but there's volcanic evidence as well. Of course, Earth is an active world. That's an important idea. We compare Earth to the Moon. The Moon is not an active world. There's not a lot of geology going on the Moon. Remember, it's shaped by things hitting it, right? So the Earth, of course, is shaped by internal forces inside of the Earth, and basically convection, heat, traveling from the center of the Earth towards the surface, and that causes, that causes geology. Basically, that's the cause of the crust changing over time. All right, so then we have Venus. I'm sorry, Mercury, Venus, and we're going to look in much more detail with each of these. There's Earth. There's our Moon, which we've already talked about, and then of course the red planet Mars. By the way, this feature right here is the largest moon in the entire solar system. It's called Olympus Mons. There's also another feature on Mars, the largest valley in the entire solar system, called Valles Marineris. All right, so we'll start with Mercury here and dig a little bit deeper. So Mercury, of course, has a radius of about 1/3 the Earth, and its mass is about it's a lot less, right? Only like you multiply the Earth's mass by about 1 divided by 28, and that fraction of the Earth's mass. It is covered with craters, as I mentioned before. It actually looks a lot like the surface of the Moon. When Mariner 10 got there, people were really surprised that its surface looked a lot like the Moon. And it doesn't have the Maria the way our Moon has Maria, but it's one of the major features that was discovered is this thing, and this is really important to understand. It's called Caloris Basin, and this was a huge. There was a huge impact. In fact, that's what the surface of Mercury was created by impacts. That's the idea. Just like the Moon, just like our Moon, created, all this surface.